we have now covered all of the transformations of a function. So what we will do now is we'll take a look at all of them together and in what order should they be done. So notice here we have a parent function f, and we have several transformations going on. So we have our input transformations, and then we have our output transformations. So with regard to the input, notice that we have to factor out so that the leading coefficient of our x is 1. So whenever we do that, the horizontal transformations will be first what's outside, and then we work our way inward. And then once we get outside of the parent function, we work from our transformations that are vertical, stretching and compression and reflections, then to our translations. So stretches, compressing, reflections go before translations in both the horizontal and the vertical cases. Notice stretching, compressing, reflections before translating. The key there is to make sure that you factored out from the inside any coefficient of x. So let's take a look at an example. So here we have the square root function again. So notice the parent function we'll identify is the square root of x. So now let's rewrite y so that we see f. So we see y equals, now what are we taking the square root of? Negative x minus 2. So instead of putting that under a square root, we're going to say it's going to be f applied to that. Then f says take the square root of that. Afterward, we add 3. Now you'll notice that the coefficient of x is negative 1. So we need to factor out the negative 1. But we can't factor it outside. It must stay within the parent function. So we have f of negative 1 x plus 2, and then after we apply the parent function we add 3. So notice the negative 1 stayed inside. So we have 3 transformations. We have the negative 1, we have the addition of 2, and then we have the addition of 3. Go ahead and think about which of these occurs first with regard to the order of transformations. So label them 1, 2, and 3. So negative 1 occurs first because it is a horizontal reflection. Then we have a horizontal translation, and then we have, lastly, a vertical translation. So let's label, or let's list the transformations that occur on the parent function. So first we have a reflection. Now is it about the y-axis or the x-axis? So the negative affects the inputs. So that's going to affect x values. So if we're affecting x values and we're changing all the x values, think about where that's changing. If all our x values are changing sign, they're going to move to the other side of the y-axis. So it's a reflection about the y-axis. Then we have an addition of 2 to the input. So that's a horizontal translation. Is it left or right? This is counterintuitive because it's affecting the input, so it will be a movement left 2 units. And then lastly, we have a vertical translation, and it's going to be up 3 units. So let's start off by graphing our parent function using the guide points, the key points that we've memorized. And now we're going to reflect it about the y-axis, and then move it left 2, and then up 3. So if we reflect it, we would get this. So this is the first translation. And then we move it left 2. And then we move it up 3. So -2, 0 moves up 3 units. -3, 1 moves up 3 units. And then -6, 2 moves up 3 units. And so this is our functions graph. So notice here, in this example, we have the graph of a function given to us. This is not a parent function that we know, but we can still transform it using the same procedures as before. So let's go ahead and rewrite y. Why do we have to rewrite it? Notice the coefficient of x is not 1, it's 2. So we need to factor out the 2. But it still has to remain inside the argument of the parent function. So we'll factor out the 2. We get x plus 4. That's the only thing that changes. So you'll notice now we have several transformations. So let's talk about what each one of these does. So what happens first? Again, we worked outside to inside on the inputs, and then order of operations on the outside. So what does each one of these do? So first, we have that multiplication of 2. That is a change in horizontal behavior. So this is a horizontal. And now it's a multiplication of 2. So is that a horizontal stretch or compression? Well, if it's multiplying by 2, it's going to be counterintuitive since it's horizontal. So it's going to be a compression. By a factor of 1/2. Then secondly, we have that addition of 4 to the input. That's going to be left 4 units. And then we have third, what's the -3 do? It actually does 2 things, and it doesn't matter which one you say first. The negative is a reflection, and since it's a change in the output, the y values will be changing. So that's a reflection about the x-axis. They move to the other side of the x-axis. And it's also a vertical stretch by a factor of 3. And then lastly, we have a movement down 1 unit. So, if we look at our key points here, 4, 0, 6, 2, and 10, 2, where do each one of these points go? So, if we have 4, 0, and we compress that by 1/2, we'll get to 2, 0. Then we'll move it left 4 units. 1, 2, 3, 4. We will reflect about the x-axis. Oh, it stays where it is. Stretch it by a factor of 3 vertically. Still stays the same. And then move it down 1 unit. So we're going to be at -2, -1. Now, we have the point 6, 2. So 6, 2 compressed horizontally by a factor of a half means that it will move half the distance, or it will shrink the distance to the y-axis by half. So instead of 6 units away, it will be 3 units away. Then we will move 4 units to the left. 1, 2, 3, 4. Now we need to reflect about the x-axis. So instead of at negative 1, 2, we're going to be at negative 1, negative 2. Then we stretch vertically by a factor of 3. So we were at negative 1, negative 2. So if we multiply that by a factor of 3, we will now be a distance 6 units away. So negative 1, negative 6. And then we're going to move it down 1 unit. So negative 1, negative 7. And then let's move 10, 2. So 10, 2 compressed horizontally by a factor of 2 will now be at 5, 2. Left 4 units will be at 1, 2. Reflected about the x, 1, negative 2. Stretch it vertically by a factor of 3, so instead of negative 2, it will be at negative 6. And then we move down 1 unit. So we'll be at 1, negative 7. And then we can connect. So let's take a look at this example. Here we know that the function is y equals the cube root of x, but we're going to move it first in part A, just 4 units to the right. So that's not bad. If I want to shift, let's call this f of x equals the cube root of x, then y would equal f of, and if we want to move it 4 units to the right, I need to subtract 4 units from the input. So y would equal the cube root of x minus 4. Now the next one is much more intense. Here we have 3 transformations, and they're not in the order we would typically expect. So let's go ahead and graph the function using their sequence of transformations, and we will adapt that graph to our sequence. So we're going to take the cube root of x, we're going to shift it up 3. So this is the original. We're going to shift it up 3. Then we're going to move it left 2. So this point becomes this point. Now let's reflect it about the x-axis. So instead of negative 2, 3, we'll have negative 2, negative 3. And we will have something that looks like that. Okay, so now let's think about how we could get from the blue curve to the orange curve using our sequence of transformations. So we could move left 2 units, and then that would move us this blue curve just would be to the left, and then we want to move it, we want to do a reflection next. So we could reflect it about the x-axis, and then lastly we can move it down 3 units. So let's put this all into practice with our sequence of transformations. So if we want to move it left 3, if we want to move it left 2, we will add 2 to x. If we reflect about the x-axis, that means that all our outputs of our function will change. So we'll have negative in front of our f, and then we'll move it down 3 units. We'll subtract 3. So this means that our function is y equals negative cube root of x plus 2, then subtract 3. Now, we don't have the full graph here on this example. We just have a point 5, 3. And we want to know what that point must be on the transformed graph. So let's take a look at what's going on with the transformation here. So we have y equals negative f of 1/2 x minus 3. So let's go ahead and get a coefficient of 1 on that x. So negative f, and we're going to factor out a half. So we have 1/2 times something. Now what can we multiply a half by to get 1/2 x minus 3? Well, clearly it will be x, because that 1/2 distributed will be 1/2 times x. Now 1/2 times what is negative 3? 1/2 times negative 6 is negative 3. So we have 3 transformations here. This is the first, this is the second, and this is the third. So let's talk about the transformation. We have first a horizontal, is that a stretch or compression? It's a stretch. It's counterintuitive because it's affecting the input. And that's a horizontal stretch by a factor of 2. Then we move to the right 6. And then after that we reflect about which axis? All of the y coordinates are changing sign, so they're going to have to move to the other side of the x-axis. So let's talk about the transformed point now. So our original point was 5, 3. So if we're going to stretch that horizontally by a factor of 2, instead of 5, 3, we're going to have the point 10, 3. Now let's move it right 6 units. We will get 16, 3. Now if we're reflecting about the x-axis, that will change the output. So that'll change our y value. So negative 3. So the new point is 16, comma, negative 3.